Hi, welcome to Easy Calculus. In this video I'll be covering integration and anti-differentiation, the basics. Okay, let's say we have a function called f of x, which is equal to 7x squared. When we go in this direction and we differentiate, we're going to get 14x. So f prime of x equals to 14x, and that's just following the differentiation rules. Now, if we were giving this function the 14x and we wanted to know what function do we differentiate to get this, that's what integration is. It's basically going backwards. So this is when you're doing integration or anti-differentiation. Same thing. Let's say we also have another function, f of x equals to cosine of x. When we differentiate and go this way, we're going to get minus sine of x. If we were given this function to begin, if we go backwards, then we're going to end up over here at cosine of x. And this would be f prime of x equal to minus sine of x. So that's the whole idea of integration. It's just going backwards. To give you a function, you've got to find out what did I differentiate to give me this function, and just going backwards is this, and from this one it's this one. Now, to get into the formal notation, okay, so here's the notation. Integral of 14x dx. That's the last problem we just did, and we found out that the integral of this is equal to 7x squared, because that's what we differentiated to get this. And whenever we have an indefinite integral, meaning there are no numbers at the bottom or the top, we have to put plus c to mean add a constant. I'll explain that in a little bit while you should do that. And with the other example we did, if we have the integral of minus sine of x dx, and this dx is saying that you're doing the integral with respect to x. So as the x changes, that's what dx means. So if it was dy, it's as y changes, what's this integral? And in this case, it's just going to be cosine x. We've got to put our plus c right there. Alright, so those are just the formal notation of what I did on the earlier board. Alright, I'm going to write out some rules now so that we can get started on actually taking the integrals. So first of all, let's say we have two things being added up inside of an integral. We can split that up. So I'm just going to say a of x plus b of x, where a of x is just some random function, b of x is some random function. We're not really concerned about what they are right now. I just want to show you that you can split them up. So this integral can be split up into like this: a of x dx plus the integral of b of x dx. And the same thing works for minus. So had this been a subtraction, we can break it up. So I'm going to put plus or minus for both of these. So that's going to be a tool that's going to be very helpful. If we have this one, let's say we have minus 5 times a of x dx. What we can do in this one is we can pull out the negative sign and the constant. So in this case, our constant is negative 5, so we can pull that outside of our integral. So we get minus 5 times the integral of a of x dx. So whenever we have a constant or a negative sign being multiplied with our thing inside the integral, we can pull that out. And that's going to come in really helpful later on, right? And it's a good idea to write these formulas down if you're not familiar with them. So the first one is that the integral of b dx equals to bx plus c. So, and b is a constant. B equals constant. So let's say b is any number. Let's call it 12. If we just have the integral of 12 dx, it's just going to be 12 times x plus c, or 12 times whatever your variable is. So that's the first formula you're going to know. That's just basically a constant formula. It's just going to be the constant times x plus c. So an example of that is if you had 6 dx, that's just equal to 6x plus c. Okay? The next one is for polynomials. If you have a polynomial like this, the integral of a x to the n, where a is some constant, x is the variable, and n is the exponent. The integral of this is you leave the a, and you're going to take the x, increase the exponent by 1. So it's going to be x n plus 1, and then divide by that new exponent. Then we've got to add c, always plus c, whenever you have indefinite integrals. So that's how you do it if you have a polynomial to the nth degree. You're going to take the, if you have indefinite integrals. So if you have x to a certain power, you can do it like this. Now this always works, except when n equals, this is for n not equal to -1. So this is going to work everywhere, except when our n is -1. And that's a special case. So if we had this integral of x to the -1 dx, let's have my dx here, or which is also equal to the integral of 1 over x dx. These two are the same thing. If we have that integral, we don't follow this rule here. We don't follow this pattern. Because we know that, what did I differentiate to get 1 over x? Well, that's ln. Because the integral, the derivative of ln of x is 1 over x dx. So this actually turns out to be ln of x. You put in absolute value just because x can be negative. And plus c. So whenever you have an exponent, as long as it's not -1, you do it this way. If it is -1, then you end up with ln of x. Alright? Now the next one is, I'll number these. So this is 1, this is 2, this is 3, 4 is going to be this one. Integral of e to the x dx. So just going back to our earlier reasoning, what did I differentiate to get e to the x? Well, the derivative of e to the x is e to the x. So the integral of e to the x is going to be the same thing, because that's what I differentiated to get e to the x. So the integral of e to the x is just e to the x plus c. That's straightforward. Now number 5, if we have integral of cosine of x dx, you've got to say, what did I differentiate to get cosine? And that's sine. So that's sine of x plus c. You've always got to add plus c for all these indefinite integrals. And lastly, if we have the integral of sine of x dx, we're going to get negative cosine of x plus c. So these are the first 6 integral formulas that are going to get us started. So we've got this one for a constant. You just, whatever the constant is, you're just going to put that b in x. And another way to look at this is, I'm going to rewrite over here, the integral of b dx, where b is a constant, is also equal to b times the integral of dx. And the integral of dx is x. So this is just x. So then this equals b x plus c for a constant. So the integral of dx, what did I differentiate to get 1 dx? Just x. Okay, so these are the formulas we're going to use to get us started. Okay, so now I'm going to show you why we need this plus c, because as far as we know, and in your class, they just told you to put plus c. I'm going to show you why you need to put it. It's saying plus a constant. So let's get into that now. Okay, let's say we had some function called g of x, which is equal to 3x squared plus 5. Then we had this other function called f of x, which is equal to 3x squared minus 20. If we were to take the derivative of g of x, so I'm going to put g prime of x, or I'm going to just say g of x. Because usually when you're doing these anti-differentiation problems, another notation they'll use is capital to denote the antiderivative and lowercase to denote the derivative. So instead of putting g prime of x, I'm just going to put little g of x, which means the derivative of this one. So that's going to be one type of notation you're going to see. There's nothing wrong with putting capital G prime, but I'm just using this notation. So the derivative of g of x is equal to 6x. Right? That's just following our differentiation rules. Now, big F, capital F, if we take the derivative, which is f of x, we're going to get 6x as well. Now let's take the integral of both of g of x and f of x. So if we take the integral, so the integral of g of x dx is going to give us our original function, capital G of x, because that's the integral of this. So this is equal to the integral of 6x dx, just substituting what g of x was. And by our rules, this is going to be equal to 6 times the integral of x dx. And we're going to go by the exponent rule. So the exponent of this x is 1. So we need to increase the exponent by 1. So it's going to be 6 times x. And this was a 1, so it needs to be increased. So now it's going to become squared. And we need to divide the bottom by that too. So this simplifies to just 3. So 3x squared is our capital G of x, which is different from up here. So that's already a problem. Let's do the same thing for f of x. So f of x is going to be equal to the integral of the derivative. And we're going to get the same 6x dx, same process, so we end up with 3x squared. But wait, capital G was 3x squared plus 5. Capital G was 3x squared plus 5. Capital F of x was 3x squared minus 20. This is missing something. Both of them are missing something. So you've got to put plus c. Because when you take the derivative of this, you lose the constant. You have no idea what the constant was when you integrate backwards. Same thing here. We lost this minus 20 for good when we integrated. So we have to put a plus c to indicate that, hey, we might have lost a constant along the way. And c could mean any number. It could be 1, 2, 3, 20, -5, 0, any constant. But we're just saying, hey, there's a constant there. Just putting it there. Hey, there's a constant here too. And they're not the same constant necessarily, because as we see here, in this case, c is 5, and in this one, c is -20. And for most of Calculus 2 integration, you won't have to find out what c is, but there will be some problems where you have to find out c, and they'll give you initial conditions, and then you'll solve for c. So it's not a big deal. But for indefinite integrals, you need to put plus c, or else I would take points off your test or your homework. Alright, so that's why you need to put plus c. Let's continue. Okay, so these are the examples I'll be covering in this basic video, so try them on your own, see if you can do them, and then you can just watch me do it. And pause the video, try and do the next step, and then try and do it on your own after. So to begin, let's do number 1. We won't need much space, I'll just raise 7. Okay, so now this format we're not familiar with, because we have the format where we have x to a certain power. So let's change this so it looks just like that. So we have the integral of x to the -5 dx. Now we're in familiar territory, because now it's x to just some power. And the way you do that is you increase the power by 1. So that's going to be x to the -5 plus 1 equals -4. Then you divide it by that new exponent, which is -4. Then you got to put your plus c. So that's the answer for that one. And there's no simplification we can do after that. So that's how you do number 1. You're going to change it to a negative exponent, just so that we're more familiar with it. And we just use our exponent rule, where you add 1 to the exponent and divide by the new one. Now for number 2,